number of or oxidation number of the central metal atom. Okay, so what we will be doing, we will be assuming it as X, then Cl. Cl is how much here? Cl, one Cl here and 2 Cl is here, so total Cl is 3, so 3. And what is the oxidation number of Cl? As I have already told you, -1 it is, plus ammonia. Ammonia is how much? 5. And the oxidation number of ammonia is a neutral compound, so it will be 0, equal to, there is no charge here, so it will be equal to 0. So X, this 3 and into 1 if you do, then it is -1, and then 5 into 0 is 0, equal to 0. Okay, in the next step what we are doing, we are taking this 3 that side, so it becomes what? +3. That means the oxidation number is how much? Oxidation number is +3. Now we are going to start the IUPAC naming of it. So as you can see here clearly, there are two ligands are there, one is Cl and one is NH3, right or not? So okay, so one is NH3, one is Cl. So alphabetically we will see, this is called chlorido, this one is chlorido, okay, chlorido, okay, and this one is amines. So which one comes alphabetically first? A comes alphabetically first. So we'll start with this. How many amines are there here? 5. So we'll write here pentaamine. Then chlorine is how much? 1. So chlorido. Okay. Now what is the compounds here? Now what is the metal atom here? Metal atom is cobalt. So we'll write here pentaamine chlorido cobalt. Oxidation number, how much we got? 3. So we'll write here oxidation number is how much? 3 in the Roman number. Okay, in the bracket you have to write it. So pentaamine chlorido cobalt, and this is what? 2 chlorine is there or not? So you will be writing as chloride. Okay, so what is the name of this compound? Pentaamine chlorido cobalt 3 chlorides. That is the name of this compound. Okay, got it, student? Okay, now we are going to do second part. Second questions. This is type 1. Okay, in this type 1, one thing you have to see, you see this is a complex, this is called as a what? Complex compounds, right? So complex compound is where? On the left hand side, right? And on the right hand side you can see that chlorine is there, counter ion is there, right or not? So that's why we have named it in the normal way. Okay, but here you see it, our complex compound is where? On the right hand side. This is right and this is left. On the right hand side it is there. So that means what? Our complex compound is negative and this is what? Positive. So when our complex compound is negative, this is ferrous, right or not? So we will not be writing as iron, we will write it as ferrate. Okay, that one already I have given you to the rules and all sort of things. So let us start. Always remember, first of all you have to answer, first of all you have to start the naming with cations. That is the positive part. Okay, so what is the positive part here? Here positive part is K or not? So we will start the naming from here. Before that we will calculate the oxidation number. So we are going to calculate the oxidation number of Fe. So Fe oxidation number is X. Potassium oxidation number is 3 into 1 plus 1, and this Cn oxidation number is -1 into 6 equal to 0. So X into 3 minus 1 into 6 minus 6 equal to 0. So it will be -3 equal to 0. So X is equal to +3. So the oxidation number of Fe we got how much? +3. Next step, what we are going to do? Next we are going to name it. But dear students, remember here first we have what? The positive part is what? K3. So K3 should be named first. So here K is how much? 3. So you don't write tri potassium. No, in this coordination compounds we will not write trienol. We will for those compounds which are outside the bracket, we will just write their name. So potassium, okay, potassium, and this is what, cyanide, right? How many are there? 6. So we'll write here 6 means what? Hexacyanide. This is what? Negative ligands or not? So in negative ligands I have already given you the rule that cyanide, E will be replaced with O. So we have replaced this potassium hexacyanido, and this is what? This is iron, but since this whole bracket part it is an anion, that is the negative part, therefore the name of this, it will be changed to ferret. Okay, first you write oxidation number. Okay, ferret, F-E-R-R-A-T, ferret. And what is the oxidation number here? 3. So we'll write the oxidation number 3 here. Hope you are understanding it little. Okay, so we will do a good number of questions so that you can understand it clearly. Okay. Okay, so students, now we are back with again another 7 questions. We are going to do this. All the 7 questions are of same type. Okay, as you can see clearly here, here it can be seen clearly that here all the complex, these are the complexes, right? These all which are inside the bracket, you can see clearly. The one which are inside the bracket, that is complexes or the coordination entities, they are all on the right hand side. Okay, they are on the right hand side, that means they are negative. And the one which is on the positive side, so these are all positive. Okay, the one which is outside the bracket, they are all positive, they are cation. And our coordination entities, they are treated as anion. Okay or not? So now always remember, when the coordination entities are anion, then the name of the central metal atom will change. Remember, this is argent. Suppose cobalt is there, so we will not write it as cobalt since it is in anionic side, so we will write it as cobaltate. Iron is there, so we will not write it as iron, we will write as ferret. Okay, aluminium, aluminate. Okay, like that, if they are in the negative sides. Okay, if the coordination entities are on the anion, then we will change the name of the central metal atom. If they are on the positive side, that means on the left hand side, then their name will not change, it will remain as cobalt only, it will remain as ferrous only. Okay, but if they are on the right hand side, that means negative, if they act as a negative anion, then their name will be changed. Okay, so let's see here. Here you can see clearly it is given here K. Okay, K is given first, so that means K is going to be positive part and the remaining thing is going to be negative part. Okay, so now let us start the naming. Before starting the naming, we have to calculate the oxidation number of central atom, that is what, Ag. So how to calculate for 1? Question number 1, we are calculating oxidation number. So let's assume our Ag ka oxidation number as X, Cn ka oxidation number, all of you know it, right? That is -1 plus K ka oxidation number, all of you know again, it is how much? It will be 1 plus 1. So plus 1, is there any positive or negative sign here? No. That means it will be equal to 0. So X will be equal to, X is 2 into -1, -2 plus 1 equal to 0. So X is equal to -1, which is X is equal to plus 1. That means oxidation number is 1. Okay or not? Now how to name it? First of all, you have to name the compounds which is outside the bracket. So what is the first? Always remember, first we are starting the naming with positive part. So positive part is this one. Okay, so K is a positive part, so we are starting the naming from here. Okay, so what is the name? potassium. Little bit space you will leave it in between. Now you are coming for the coordination entities, so little space will be left. Now here, which one is the ligands? Inside the bracket, first we will write the name of ligands. So CN is the ligand, so we'll write here how many CNs are there? 2. So di, what is it? It is negative. CN is negative, so we'll write here what? Dicyano. And then I told you coordination entities, this is what? Negative part, so we'll write here argentate. And what is the oxidation number we got? We got 1, so we have written it 1. Okay, hope you have understood. Now let's go to question number 4. Okay, question number 4, let me solve it for you, how it has come. Question number 4 ka, first of all we have to calculate what? Oxidation number. Okay, so oxidation number calculating, we are calculating for Hg. So let's assume it as X. K, how many are there? 2. And K ka oxidation number is 1. Chlorine is how much? 4. What is the oxidation number of chlorine? -1 equal to 0. So X plus 2, and this one will become -4 equal to 0. So X minus 2 equal to 0. So X is equal to +2. So oxidation number of Hg, this oxidation number of Hg is how much? +2. So what we are going to do here, now oxidation number of Hg is 2. Okay, fine, we got it. Now what we will do, we'll start the naming. So always remember, positive part should be named first, and here K is positive and this whole bracket wala inside is negative. So K, what we will be writing it? Potassium. And how many chlorine are there? 4. So tetrachlorido, we'll write it as what? Tetrachlorido. And since this inside the bracket wala it is negative, it is on the left hand side. Okay, right hand side wala it is second. So it is mercury, but its name will change into mercurate. So mercurate, and oxidation number is how much? 2. So 2. Hope students you are understanding it. Okay, next let's go to question number 5. Question number 5, how we are doing it, let's see. So question number 5, we are going to calculate the oxidation number of platinum. So let's assume it as 5. Okay, let's assume it as X. Okay, plus how many potassium is there? 1. So 1. And how many chlorine is there? Chlorine oxidation number is how much? -1 into 3. And this is ammonia. Ammonia's oxidation number is 0. So here it will be +1 minus 3 equal to 0. So X equal to X minus 2. So X equal to +2. So oxidation number of this one platinum, we got how much? +2. Now naming. Again you see, first is what? K. If this bracket is in the first, then we'll name this bracket first. But bracket is in the second, so first is what? K. So we'll name it. What is the name of it? Potassium. Whether it is K2, K3, whatever is there outside the bracket, we are not writing di, tri and all. Okay, we will write only potassium. So here it is written potassium, and this is what? Chlorido. This is what? Amine. So which one come alphabetically first? Amine. So we'll write here amine first. Okay, alphabetically you have to see amine. Then how many chlorine is there? 3. So we'll write here trichlorido. And this name is platinum, but since this box is get an anion part, that is negative part, so the name will be written as platinate. And what is the oxidation number? 2. Okay. Now coming to question number 6. Okay, question number 6. Question number 6. Let's do it. Question number 6. So in question number 6, you can see we are going to calculate the oxidation number of this cobalt. Okay. So our first one is what? We will assume it as X, and Na, that is sodium. Sodium oxidation number is how much? +1. Okay. So we'll write just 1. Then NO2, that is nitrites. So that oxidation number will be -1 into 6. 6 are there, so equal to 0. So X equal to +3 minus 6 equal to 0. So X minus 3 equal to 0. X is equal to 3. So oxidation number we got it how much? Plus 3. Now let's start the naming. Again you see Na, it is first, so we have to name it first. That is the positive part, and this bracket wala inside is all negative part, so we have to name it accordingly. First, always remember in IUPAC naming of coordination compound, the first name we start from whom? First we start the naming from the cation parts. Okay, so here sodium, 3 sodium is there, so we are not going to write it trisodium, only sodium. So we'll write here sodium, and how many NO is 2 is there? 6. So we'll write hexanitrito. Now what here you see dash N I have given, means what? Here in nitrito you can see N and O is there, but the bonding will be done through N. Okay, again I am telling, in nitrito NO2 is there, but the bonding will be done here through N. That's why we are writing it here nitrito N. Okay, already I have discussed with you these things in the previous lecture. If you have not watched it, please go to Kumar sir and channel Kumar sir and watch it. Okay, so nitrito N, and then next is what? Cobalt. So cobalt, since this is negative part bracket wala coordination entities, so we'll write it as cobaltate. And what is the oxidation number we got? 3. So we'll write it here 3. Okay, got it? Okay. Fine. Let's move to the next one, that is question number 7. Hope students you are understanding it. Okay, if you have studied the if you have properly gone through the previous lecture and the notes which I have given, definitely you will be understanding this. If not, then once again you have to go to my channel Kumar sir, watch the previous lecture number 1, lecture number 2, then only you will be understanding this. Okay or not? Okay, let's start with question number 7. So question number 7, Fe. We are the central metal is Fe, so we are going to calculate for Fe. So Fe is X. We are potassium oxidation number is 1, so 3 into 1. Cyanide it is -1, and how many cyanide are there? 5. So 5, and NO ka oxidation number is how much? 0. So 0 equal to 0. So X plus 3 minus 5 equal to 0. So X 3 minus 5 is how much? Minus 2 equal to 0. So X is equal to what? Plus 2. So oxidation number of Fe is how much? Plus 2. Okay. Now let us start the IUPAC naming. Again you see here also K is first. So we'll name it first, and this coordination entities will be treated as negative, and this one is treated as positive. So potassium, then cyanido, and this is nitrito. So nitrosyl. So N, and this is C. So C come alphabetically first. So potassium, how many cyanido is there? 5. So cyanido or cyano, it's same. Cyano, and this is called as nitrosyl. It is a neutral ligand. Already I have given you the notes on it and lecture on it. Please go through it properly, then you will understand this. So pentacyano nitro, this is nitrosyl, and since this coordination entity is negative, the name of the central metal will change, and it will change like this. It will be ferrate, and what is the oxidation number? 2. So we have written in the bracket 2. Okay, so this is all about question number 7. Now let's go to question number 8. So question number 8 is also easy, students. This one you have to learn it properly. It's very important for your board examinations. Okay, so you have to learn it properly. Now let's see here. So here also Fe is there. Okay, so we'll assume our coordination number of Fe as X, and K3. K ka oxidation number is 1 into 3 plus C2O4. So C2O4 is nothing but, student, it is oxalate ions. Okay or not? It is treated as oxalate. Okay, so oxalate, already you know the oxidation number. These things already I have given. Oxalate oxidation number is -2, and how many oxalates are there? 3. So into 3 equal to 0. So X plus 3 minus 6 equal to 0. So x minus 3 equal to 0, x equal to plus 3. So oxidation number here it is how much? 3. Now let's start the naming. So first is what? Potassium. So we have written here potassium. How many oxalate ions are there? 3. How many ligands are there? C2O4. How many are there? 3. So try these compounds or ligands is called as what? Oxalate. So it will be changed into oxalato. Okay, oxalato. Now since this whole coordination entities, that means inside the bracket, while this is second part, that means negative part, so the name of the central metal will change. It will be written as ferrate, or else if it is not a negative part, then it will be written as ferrous. But now it is written as what? Ferrate. And what is the oxidation number we got? 3. So we have written it here 3. Okay, now coming to the question number 9. Okay, so question number 9, students, you can see it here. We will assume again that our central atom is what? Nickel. So nickel the oxidation number we are assuming it as X, and the potassium oxidation number is how much? Plus 1 into 4 plus cyanide, it is how much? Minus 1. Minus 1 into 4 equal to 0. So x plus 4 minus 4 equal to 0. So it will be x equal to 0. So the oxidation number here of nickel will be how much? 0. So let's start the naming. First we will start the one which is on the left hand side. So left hand side, what is there? K4. So potassium. Okay, next ligands is what? Inside the bracket. When we will come inside the bracket, remember you have to name the ligands first. Okay, ligand should be named first, and that one also alphabetically. So this one is what? Cyanide. So it will be, how many are there? 4. So tetracyano. And then nickel, its name is nickel, but this coordination entity is negative, so the name will change into nickelate. N-I-C-K-E-L-A-T-E, nickelate. Okay, and what is the oxidation number here? 0. So we will write it as 0. So dear students, this is type 1 of nomenclature of coordination compound. Now type 2 of nomenclature I will I'll be teaching you in the coming lectures. Okay, so I hope you have understood it. If you have any doubt, feel free to ask. Okay, so students, now we are going to do type 2. I have not mentioned here, but this there are two types of two types are there. IUPAC name of a coordination compound. First type already we have discussed. Now second type. See, in the second type, what is the difference here? In the first type, you have seen that this bracket was in the second part. Okay, and first was K, Na, and all like that. So that means K, Na, it was all acting as a cation. That means positive part, and this bracket was acting as a negative part. But here, the coordination entities, the bracket is in the first, so that means they are positive. So the name of the central metal will not change for this kind of compounds. Okay, it's very simple. Okay, got it or not? So let's start the naming. First of all, let us calculate the oxidation number. So question number 10, oxidation number, let us calculate. Let's assume that platinum ka it's X, then chlorine is how much? 1, so minus 1, and NO2 ka oxidation number is minus 1, ammonia ka it is 0. Okay, ammonia it is how much? It is considered to be 0, and plus sulfate is outside, right? So sulfate ka oxidation number is minus 2 equal to 0. So X equal to minus 1 minus 1 minus 2 equal to 0. So how much? Minus 4 equal to 0. So X is equal to how much it is coming? Plus 4. So oxidation number we have mentioned here as how much? Plus 4. Now coming to the naming. So now first is our coordination entities. So we'll start the naming from this one first. These are the counter ions. Okay. So now coming inside the coordination entities, that is inside the bracket. Now you see this is chlorido, this is nitrito, and this is amine. So alphabetically this one comes first. So we'll start here. Okay, tetra, T-E-T-R-A. Don't think that I made a mistake here, not writing capital. It should be written only in a small letter. Okay. So tetraamines, okay, and then comes chlorido C, that is chlorido, and then NO2, that is nitrito, and here the bond will be formed through N, so N. And what is this? Platinum. So we have written platinum. What was the oxidation number? 4. So 4 sulfate. Okay. See here, name is not changed. Platinum means platinum only. Why? Because they are the positive part. The coordination entities is positive. It is in the first. But if it is in the second, then the name will change into platinate. Okay. Which one we have done in the previous type of questions. Okay. Now let's move to question number 11. Okay. Now question number 11. Now let's calculate the coordination oxidation number of cobalt. So 11 oxidation number of cobalt. Let's assume 1 x. Chlorine is how much? 2. So oxidation number is how much? -1. NO oxidation number is how much? -1. And NH3 it is 0. Neutral compound, so it will be equal to 0. So x minus 2 minus 1 equal to 0. X is equal to +3. So oxidation number we have written it here as +3. Now let's see the naming. Here this is chlorido, this is nitrito, and this is amine. So we will start from here, A. So triamines, 3 are there, so triamines. And how many chlorine is there? 2. So dichlorido. And then what is this? NO2. So nitrito. The bond is formed through N, so we are writing it here dash N dash. What is the name here? Cobalt. So we'll write it cobalt 3. Again I am telling you students, in the previous questions, question number 3 to question number 9, we have done questions where the name was changed because the coordination entities was negative, but here coordination entities is positive because they lies in the because it is in the simple way you can say it is in the first, so it is taken as positive. If it will be in the second and before that something is there, then it will be treated as negative. Okay. Now question number 12, let us try to do it. Okay, question number 12, quickly let us do. The video is getting lengthier. Okay, so question number 12 here, chromium ka oxidation number we are going to calculate. So let's assume that it is x. Chlorine is how much? 2. So let's write -2 directly. H2O. H2O, as I have already told you in the previous lecture, it is a neutral, so it will be 0. Okay, since it is neutral, so it will be 0. NO3 is how much? -1. NO3 is -1 equal to 0. NO3 ka oxidation number is -1. So x minus 2 minus 1 equal to 0. So x is equal to +3. So oxidation number we have written it as +3. Okay, now you see here how we will start. This is chlorido. This is, what is the name? This is exceptional neutral ligands. As I have already given you the notes, if you have not studied, please feel free, go to your channel Kumar sir and study lecture 1 and 2. First you watch lecture number 1 and 2 and then you can come here. Okay, so this is what? H2O. So it is a neutral ligand, so it will be treated as its exceptional case. Its name is aqua. So we'll write here how many are there? 4. So tetra aqua. How many chlorine are there? 2. So dichlorido. And what is this? Chromium. So chromium 3. Oxidation number we got 3. And this is what? Nitrate. So nitrate. Okay, students, I hope it is clear. Now let's go to question number 13. Question number 13 is little different. Okay, it's same only. If you have watched the previous lectures on this chapter, it will be easy. So let's calculate the coordination oxidation number of cobalt first. So let's assume it as x. Br, that is Br oxidation number is -1 into 2, and En ka oxidation number is again -1 into 2, -2, and this one En, it is treated as what? Neutral ligands. Okay, so this one chlorine ka its oxidation number En, it will be taken as -0, and Cl, it is -1 equal to 0. So x equal to -2 minus 1 equal to 0. So x equal to +3 oxidation number. Okay, got it? Understood everyone? Okay, now let us go to the naming. So here this is called as bromido, this is this name already I have taught you in the last lecture. Its name is what? Ethane 1,2 diamines, okay, or ethylene diamine we call it as. So it starts from E and this starts from B. So first we will start with the B. So how many Br is there? 2. So dibromido. And if like this kind of compound ligands are there, or py2 or dgm2 like that is there, then remember we cannot use here di. We have to use in such compound as what? Bis. If it is 3, then thrice. Okay, like that we have to use it. So it will, how many are there? En 2. So we have written here bis. This is a different types, so you should listen it properly. This one, okay, these are all didentate ligands, so we have to write here bis. We will not write here di. Okay, so we have written here bis, and this name should be inside the bracket, ethane 1,2 diamines, the name of these compounds. And then what is the ligands? Cobalt. And oxidation number, how much we got? 3. So 3. And what is outside? Chloride. So outside one we will not write chlorido, okay, or bromido. We'll write their normal name, that is chloride only. Okay, only when they are inside, when the ligands, when they act as a ligand, their name will be changed into chlorido, fluorido, bromido. Okay. Okay, students, I hope you have understood it. Now let us come to the last questions of this video. NiCO4. Okay, so here let's calculate the oxidation number of NiCO. It is oxidation number is 0. So 0.